All right. We're going to be needing this today. We're starting, let me show you. We finished all these already. We finished all these already. Chapter 3, section 8 and before. Now we're jumping onto, when you do your homework, now you're going to go to your Dmat 0317. For the next two chapters, 5 and 6, your homework will be there. And your test will be there for these two chapters. All right, so don't go back to your 1332, go to these. Now we're doing the math part. So that's very important. Do not, so I don't want to receive messages, I can't find the homework. Yeah, because you're in the wrong place. So we're in the 0317. Chapters 5 and 6 deal with the rules of math and the basic operations of math. That's what we'll be doing the next couple of weeks. Probably from now until spring break. That's in 2-3 weeks. All right. How many of y'all ever knew that there were rules on how to do division? I didn't either until I looked all this stuff up. For example, everything's divisible by 1. Duh. Divisible by 2. How do you know something's divisible by 2? If the last digit's an even or 0 integer. Divisible by 3. If you add up all the digits in the number and that sum is divisible by 3, then the whole number is divisible by 3. For example, so this is Dmat 0317, day 9, 2/21/23. The number 117. Is that number divisible by 3? Is it divisible by 2? No, because it doesn't end in even or 0. Is it divisible by 3? Yeah, if we take the numbers 1 plus 1 plus 7, is this number divisible by 3? Yeah, so since that number is divisible by 3, since this number is divisible by 3, that means this whole thing is divisible by 3. 3 goes into 11 how many times? 3 times. 3 times 3 is 9. 11 minus 9 is 2. 3 goes into 27 how many times? So we know that 117 is divisible by 3 and 39. And we're going to talk about that in a little bit itself. A number is divisible by 4 if the last 2 digits of the number is divisible by 4. Another way you could do it is if it's divisible by 2 twice. If you can divide it by 2 twice, then it's divisible by 4. Or if you look at the last 2 digits, for example, is that number divisible by 4? So you look at the last 2 digits. Is 36 divisible by 4? Yeah. 9 times. So that means this whole number is divisible by 4. 4 goes into 5 how many times? Subtract them. Bring everything else down. 4 goes into 17. 4 times. 4 times 4 is 16. 4 goes into 13. 3 times 4 is 12. And 4 goes into 16 4 times. So you don't have to waste your time. Is it more importantly, you don't have to use your calculator. Because it's amazing how we're a first world nation, and yet our math abilities are below third world nations. In other words, if we lose all power, if anything happens to our electric system, we're the dumbest in the world. We can't do crap. Because we're so dependent on our cell phones, our calculators, that we can't do anything ourselves. So imagine what happens there. So I want you to do is look at the rest of these and practice those, because we'll have little sample problems next class. I'm going to ask you, is this number divisible by which digits? Because we're going to need to know these to do what we're going to talk about today. All right. So we're dealing with chapter 5, section, well, it's chapter 5, it's section 1. And that deals with natural numbers. Prime and composite numbers. So the first question I have to ask you, what is a natural number? The symbol of a natural number is this. If I ask you to count, where do you start from? And you keep on going. So 1, 2, 3, 4, and so on and so forth. Those are the natural numbers. Then we go a little bit further. We have whole numbers. It's the natural numbers starting with a whole. 0, 1, 2, 3, 4, and so on and so forth. Those are called whole numbers. You see how we're building up the number system from positive numbers to 0. Now what do we need to add? The negative numbers. So the set of numbers that include all the negatives, 0, and all the counting numbers are called integers. What integers symbol was, I'll remember that. So that's all the negative numbers, 0, and all the positive numbers. Those are natural numbers. Now, what are prime numbers? What makes those prime numbers? Yes, those are prime numbers. Yes, 1, 3, 5, 7, 11, 13. But what do those all have in common? They cannot be divided by anything other than prime numbers are numbers that can only be divided by 1 and itself. Those are prime numbers. Then we have the other half, the other side of numbers. Composite numbers. What is a composite? Composite material is something made up of other stuff. These are numbers that have other numbers that can be evenly divided into them other than one and itself. So give me an example of a composite number. 4. Why is 4 a composite number? Yeah, because 4 is made up of 1 times 4 or 2 times 2. In other words, these numbers, 1, 4, and 2, if I divide 4 by them, do they equal an integer? 4 divided by 1 is what? 4. 4 divided by 4. 4 divided by 2. Yeah. See, so we have other divisors that go into those numbers. Those are composite numbers. What do we call the process when we break down composite numbers or prime numbers? Factorization. That's a Z. That's a Z. Factorization is when factor the products of a number. What does it mean, products? When I say products, what do I mean? Sum is a different word. Sum means addition. Product means times, multiplication. So when you, these are the, like here, 4 times 1 is 4, 2 times 2. So it's the product. So when I factorize something, the most common method is called the tree method. If I start with the number, let's say 18, break it down in its first 2 pieces. What 2 numbers multiply to give you 18? 9 times 2. Can 9 be broken down any further? 3 times 3. Can 3 and 3 be broken down? No, it's a prime number. How about 2? No. So the prime factorization of 18 is 2 times 3 times 3. Can you think of a use of why we would do that? Why would we prime factorize numbers? Okay, then prime factorize this number. Go ahead and do it, and then I'll see if we got the right answer. So it ends in a 2, so I know that 2 goes in there, right? How many times does 2 go into 5? 2 times, with 1 left over. Yes. Yes, so yeah, well, no, I just always divide, but I'm looking at 52 is made up of 2 times, well, how many times does 2 go into 12? So 2 times 26 is 52. Okay, 2 is that's as far as you can go. 26 is made up of what? So 2 times 13. 13 is made up of, it's a prime. So 52 is made up of 2 times 2 times 13. Now, here's a common use of prime factorization. Divide those 2 numbers. When you divide, you're looking for what they have in common, right? So what is 18 made up of? 2 times 3 times 3. What's 52 made up of? 2 times 2 times 13. If we cancel anything that's same on top and bottom, that's called simplifying it. Can anything else cancel? No, so now we multiply. 3 times 3 is 9. 2 times 13 is, and that's as far as you can go. You can't go any further. So there's a reason for prime factorization. Yes. That's as far as you can go. Because if you can simplify it, it would cross out here. But since everything's canceled, they can, nothing in here can cancel. Okay, that's called prime factorization. Now, when you factor something, when you factor a number, for example, let's look at 18. What is 18 made up of? It's made up of 9 times 2. 6 times 3. And 1 and 18. So when I factor 18, my factors are 1, 2, 3, 6, 9, and 18. Because 1 times 18 is 18, 2 times 9 is 18, 3 times 6 is 18. Those are all the factors. These are the factors. I'm looking for what are all the multiples of this number. So you see now why it's important to have this division table here? Because now you have to see what goes in there. Is this number divisible by 3 or 5 or 7? Once you have that, then you're good to go. So far, so good? Find me the prime factors of 213. All right, so the prime factors of 213, since we know we add up all digits, equals 6, and that's divisible by 3. So we know 3 goes in there. 3 goes into 21 7 times, 3 goes into 3 once. So 3 times 71 is a product that equals 213, and so is 1 times 213. So the factors of 213 are 1, 3, 7, 213. Other ways we can represent this is saying 36 is divisible by 6, which is the same way of saying 6 is a divisor of 36. 6 divides 36, or this symbol. These mean the same thing. If it's not, 5 is not a divisor of 36, we'll put a line through it, like we do the other algebraic symbols. Is 4 a divisor of 3,074,086? No, because the rule of 4, does 4 go into 86? No, so 4 is not a divisor of this whole number. Is 9 a divide? Does 9 divide into this whole number? Yes, because if we take all the digits, add them together, 36 is divisible by 9. So 9 does go in there. It's a divisor. The fundamental theorem of arithmetic says every composite number can be expressed as a product of prime numbers in one and only one way. Order is not important. Yeah, the factors of 90 are 10 times 9, 15, 6, 330, 45, 2, and 8. But if we prime factorize it, these are the factors of prime numbers. They can only be put together one way to equal 90. Now we're talking about greatest common divisor. So what's the biggest number that goes into both 24 and 8? So if we prime factorize both of them and see what they have in common, then we know that 8 is the greatest common divisor. Brings us to this one now. We have to take 216 and 234. So what do we know goes into 216? 2 or 3? Okay, let's go 3. Well, we know that 6 plus 1 plus 2 is 9. I mean, all these are true. There's multiple ways. But I always look at the first one. Is it, if it's an even number, I start with 2. 2 goes into 21 how many times? Or 2 goes into 20, 2 goes into 2 once. 2 goes into 16 how many times? 8. So it's 2 times 108. 108 is made up of, since it ends in an even number, 2 goes into 10 5 times, 2 goes into 8 4 times. 2 goes into 5 twice with 1 left over. 2 goes into 14 7 times. 27 is made up of 3 times 9, 3 times 3. So 216 is made up of 2 times 2 times 2 times 3 times 3. Let's look at 234. 2 goes into 2 once, 2 goes into 3 once with 1 left over. 2 goes into 14 7 times. 2 doesn't go in there, but 7, 8, 9. So we know 3 goes in there. 3 goes into 11 3 times with 2 left over. 3 goes into 27 9 times. 3 goes into 3 once, 3 goes into 9 3 times, and these are prime numbers. So what's the answer to this one? What's the greatest common divisor? What do they have in common? They have a 2, and they have 2 3s. So 3 times 3 is times 2. That's the greatest number. 18 is the greatest number that fits in both of those. It has to be made up of those numbers. So let me look for some more examples here. Okay, everybody okay with the greatest common divisor? So you're looking for the biggest number that goes into both or all the numbers. If you have multiple numbers, if you have 5 numbers, you have to do the same thing to all of them and see what they all have in common. Okay. Another one. Least common multiple, the LCM. This is the smallest number that is divisible by all numbers in the set. It's the smallest number that is divisible by the numbers in the set. So what's the smallest number that 15 and 20 both fit into? Does 15 fit into 5? Well, let's look at this. Let's see it. So 15 times 1 is 15. 15 times 2 is 30. 15 times 3, 45. 15 times 4, just add 15 to 45. 60. 15 times 5. One more. 15 times 6. And keep on going that way. Pretty much at each step, we just add 15. Do the same thing. 20 times 1 is 20. 20 times 2 is 40. 20 times 3 is 60. 20 times 4 is 80. And so on and so forth. So what's the least common multiple? What's the smallest number that these two numbers both fit into? Very good. 60. Yeah. I know y'all have seen this before, but yeah, now this is how it works. It's the smallest number that every number in that list fits into. Let me see. Find the LCM here of 144 and 300. Don't do it that way. It'll take you a long time because this one jumps by 300 each time. This one only goes to 144. So your list will be pretty long. I'll show you why. What are the factors of 144 and 300? 2 goes into 144 how many times? 2 goes into 14, 7. 2 goes into 4 twice. 2 goes into 7 how many times? 3. with 1 left over. 2 goes into 12 6 times. We know 6 times 6 is 36. So far, so good. So we have 1, 2, 3, 4. We have 2, 2, 2, 2, and how many threes? 2 threes. $300 is made up of 3 times 100, 10 times 10, 2 times 5, 2 times 5. So how many 2s do we got? So it's 2 to the 4th. How many 3s? We got 2 in 144. On the bottom one, we have 2 squared, 3, and then 5 squared. Now, since we're talking about the least common multiple, out of our 2 lists, here and here, take the numbers that have the highest exponent. So in this first one, who's got the highest exponent for the 2s? The top one. So we have 2 to the 4th. How about the 3s? This one only has 1, this one has 2, so we use 3 squared. And this one just has 5 squared. So the LCM is just that. Once you prime factorize them and you put them in exponents, how many times the numbers are repeated? If they have the same numbers, whoever has the highest exponent, you use that number. If they both have this, if they both have, let's say they both had 2 5s, then you just use 5 to the power 2. Just one once. So now we multiply these out. 2 to the 4th power is 2 times 2 is 4, times 2 is 8, times 2 is 16. 3 squared is 9, 5 squared is 25. 9 times 6 is 54. 9 times 1 is 9, plus 5 is 14. $144 times 25. 20, 22, 7, 8, 8, 1, 0, 0, 6. That's 2. That's 2. And so the LCM is 3,600. You see why I said don't do it the other way? So if the numbers are large, do it this way. If the numbers are small, then add them out, see how they go. So that's the other ones. Let's try smaller ones. 80 and 120. Find the LCM. Are you okay? Ever get these factors? So it's 2 to the 4th times 5. 2 to the 3rd times 3 times 5. So what's the LCM? Which of the 2's do I take? The top or the bottom? Yeah, so it's 2 to the 4th. How about the 3's? Just a 3. And they both have 1 5. 2 to the 4th is 16. 16 times 3 is 48. Bless you. Minus 40. So the LCM is 240. Pretty straightforward. So that's the GCD LCM. That does it for section 1. Well, next section we're going to do on Thursday is the order of operations, and now we're getting to the algebra part. But these tell us on how to separate numbers and when we need to solve for larger equations. All right, that's it for section 5.1. You'd heard correctly. I was going to tell you that, yes. There is no school Thursday or Friday for y'all. Even online courses, evening courses, everything's canceled because the faculty and staff are in professional development training.